in section 6.4, we're going to look at graphing logarithms, and you're either going to need a graphing calculator to do this, or as we've mentioned in previous classes, you could always use Calculate 84. It has the same exact features. So to graph y equals log base 2 of x, we're going to go to y equals, clear out anything that's in there. Since I have a base other than 10 or e, we're going to hit math, and then we're going to go down to our log base, which is a, and I'm going to just type in 2, and then we have x right here. Like I said, you can do the same exact thing on Calculate 84. From there, I'm going to go ahead and actually see what the graph looks like. Okay, so to get a rough idea, I see it comes down, it approaches x equals 0, it doesn't touch it, and then we're curving up to the right. I want some good points here. So good points. We're going to have one at 1, 0. So we got a point at 1, 0. Then we have another one at 2, 1. Okay. From the other day, we do know that you cannot take the log of 0 or negative numbers. So I'm coming down here for my asymptote. I'm just all the way down, and then we're curving up, going to the right like that. Domain on this. It's going to be every x value greater than 0. Okay, we can't touch 0 at all, so it's every x value greater than 0. Range is going to be all real numbers on this. X-intercept is when y is 0, so I cross at x value 1, so we have 1, 0. My asymptote, so the line I get close to but not touching, is going to be x equals 0, so I'm going to go ahead and throw a dotted line there. And then our end behavior, as x goes to 0, my graph is going down, so we're going to negative infinity. As x goes to the right, okay, we are going up for forever, so we are going to positive infinity. Okay, so again, with that, you're going to use a graphing calculator to graph them. Use it to get like a rough idea of what the graph's going to do, and then get at least 2 good points from the table. Example 2, they want transformations. Okay, really the big thing on this is I want to know like what is the transformation that's going on here. So it follows the same exact rules that we've done all year. Next to the x would be left, right, outside's up, down, and then out front would be a stretch, reflect, anything of that nature. So for this one right here, we are going left 3. Okay, that would be our transformation on that one. We can go ahead and graph it again if you don't feel confident finding points. So go ahead and type it in. I got log base 2 of x plus 3. Graph it. And as you can see, everything got shifted left 3 points. So my asymptote is now at x equals negative 3. Okay, so we're over there. Let's get some good points. We got negative 2, 0, negative 1, 1. And then we're going to curve up through there like so. Answering questions. This time it's every x value greater than a negative 3. Range is still all reals. X-intercept, we're crossing at negative 2, 0. And my asymptote would be x equals a negative 3 on this. End behavior, we got to fill some stuff in. So as x approaches negative 3, our graph is going down still. And then as x goes to the right, we're going up. So we're going to say that goes to infinity. Okay. So that's example 2. The extra example 2, I'm not going to like so much worry about graphing it, but you do need to be able to tell me the transformations that are going on. So our negative sign out front tells us that we are reflecting over the x-axis. The plus 3 on the inside tells me that we're going left 3. And then the minus 4 on the outside tells us that we are going down 4. Okay, so those are the transformations from there. Again, you could graph it by typing in the calculator. I'm not going to bother doing it for that one. Okay, the last example we have in 6.4 talks about inverses. Really, we cover this in 6.3, but it's a good refresher. For an inverse, you're switching x and y. Okay, so for this first one, if I switch x and y, I'm going to have x equals 10 to the y plus 1. And then we know that for an inverse, we want it to be y equals when it's all said and done. So to make this y equals, I'm going to have to switch from an exponential to log form. So remember, switching to log form, our bases are always the same, so I got log base 10. The log always equals the exponent, so y plus 1 goes to the right, and we have x right here. So to get y by itself, I have to subtract 1 from each side. In doing that, I'm going to be left with log x minus 1. Notice I didn't put a base there, and that's because when the base is 10, we don't need to include it. So y equals log x minus 1 is good to go. Really, I guess to be official, I should have put f negative 1 of x. So f negative 1 of x. That tells me that, hey, we got the inverse going on. This is log x minus 1. Over here to the right, same deal, switch x and y. So I got x equals log base 7, y plus 5. Again, you need to get y by itself. So to do that, we need to switch forms, get an exponential. So I take my base, raise it to the exponents on the other side. Give me 7 to the x equals y plus 5. And then getting y by itself, you subtract 5 from each side. So y equals 7 to the x minus 5. And I'll do it right this time. To signal that it's an inverse, you go f negative 1. So f negative 1 of x equals 7 to the x minus 5. And that is section 6.4.